So the last one we're going to do is about precipitates. So, you know what a precipitate is. So we're going to do kind of like a green level question now where we're doing an application. So first we'll just fill in these notes. So a precipitate reaction, which you should have noticed. Do you not have this?
Well, no, I think we skipped something.
Oh. Did I just change the order?
Because blank is a process used to blank the pressure.
Oh, well, just skip that for a minute. So a precipitate reaction is a double replacement, remember like the double dating kind of scenario, in which a solid product is formed. Remember, a new product, okay? That's the precipitate. You can add a known, so this is kind of a green level question now. You can add a known solution to an unknown solution to see if a precipitate forms. Okay? I'll show you examples of this. This can help you distinguish between possible ions in an unknown solution. So, for example, you will need your solubility charts out and ready for this. So, you're told you have a solution that may contain either aluminum ions or potassium ions. What solution could you add to the unknown to determine the type of ion present? So what I do first is write down what you possibly have, either aluminum ions or potassium ions. Now, what you need to think to yourself is, what could I add to this solution, this unknown, that say either that one of these ions will make a precipitate with, but the other will not? Okay? So, this is what you need to think to yourself. What, or I'm going to say which ions, which ion can I add to the unknown solution where one ion can make a precipitate, but the other will not? So, for example, I'm just going to kind of start going through this and showing you what I mean. So on your solubility chart, let's think, what if we added, say, ammonia? Okay, I'm just going to erase this. So ammonia could be an option. So what if I take ammonia and add it with aluminum? Do I get a precipitate? So look at your chart, find ammonia. Where would it fit with aluminum? In the most category, right? So it would be no precipitate. Okay? What if I took ammonia and added it with potassium? Do I get any sort of precipitate? No. This was maybe a silly choice because it's like a cation plus a cation, but I was just kind of going through the process with you, okay? So let's choose, do you guys have a suggestion of what I could try? OH minus, okay. So if I have OH minus and aluminum, so I go to my ions, OH minus, group 1 ions it's soluble, NH4 it's soluble, but everything else is in slightly soluble. So this one would definitely make a precipitate of Al bracket OH3 solid. Okay? So if you were giving an answer for this, you would write out that equation so that you could kind of justify your reasons. But now let's see if I took OH minus and I add Na plus. If I go to my solubility chart, Na plus is a group 1 ion, so it definitely fits in the soluble category. So then that's NaOH aqueous. So that definitely is a great answer, is using OH minus. So if you took a solution that had OH ions in it, it doesn't actually really matter what type of solution it is, because as long as the other ion can act as a spectator. Okay? So you would need a solution that contains hydroxide ions is your answer. Okay? And then you could give me an example of that and say that would be like potassium hydroxide, because it has to be a solution, right? So you have to choose something that goes with it that is actually aqueous. So for example, let's say for example, potassium hydroxide aqueous. Okay? So that would be how to answer this question. Okay? There is often multiple correct answers though, right? You can see that. So so you guys could all have different answers for those responses in the workbook. Is there another one? Is that it? Is that it for your notes? Yeah, okay. So it looks messy.